This video is going to show how to make a drawing file from your Polygon Cam, Eccentric Cam, Pear Cam, and Snail Cam. So let's get started with the Polygon Cam. Before we get started, we want to talk about a couple of issues. If I want this to be my front view, first of all, there's a couple ways we can look at that. There's a little tab down here called Look At. If you click on any flat surface, it will bring you perpendicular to that view. But I have a problem. If I want this to be my front view, notice on the view cube, it's the left. That's not good. So what I want to do is make sure that I'm looking straight at it using the Look At tool or the view cube, and then come down with this little drop down menu here, and we're going to reset our current view as front. And that's really important that we have our front view, top view, and right side view the way that we want it to be before we make the drawing file. Now let's say you really messed up and you did something like reset this current view as the front view. Notice that it will change the view cube, and now if I look at my front view, that is my front view. Not exactly what we want. So again, you can use the Look At tool to bring yourself into a perpendicular direction, and we can reset this current view as front. Okay, so we want to do that. I want to save this before I move on. That's really important, or it's not going to show up when we do our drawing file. All right, so now we're ready to go do our drawing file. Design, drawing, from design. Now I have my own template in here. You can use just the standard that comes up if you want. And here comes the drawing file. So now when I come to, it remembers the last thing that we did. We're making the drawing from that. So right now it is bringing in the front view the way I want it to be. And I don't really necessarily like the scale. So I think I'm going to try just 1:1, and let's see how that looks. We could even go bigger. Let's try 1.5. We want to use paper and make things as clear as possible. I like that. So let's place our front view by clicking and clicking OK. Now I did make a little mistake I'll come back to later. Now we want to project this view. Click project, click on the view you want to project. Now we only need to show the thickness in one place. I do not need a top view and a right side view because all those views are going to show the thickness of this object. So I think I'll just choose the right side view, click, and then come up here and set the isometric view, click. And there's a little check mark to say create and continue, or you could hit enter. Now we have a little problem. If you notice, the right side view does not have hidden lines, and it should, because it should show where that hole is going through. So we can come back here, double click on the front view to edit it, and turn on visible and hidden edges. Now what that's going to do is it's going to make the change to the front view and any view that was projected from it, because these are children of that view. Now the isometric shouldn't have hidden lines, so we can double click on that and change it to shaded. All right, now we're ready to go to put in some reference symbols, like the center mark in the middle of the symbol, or in the middle of the circle, excuse me. And we're going to bisect these two hidden lines with a center line. It's called a center line bisector by clicking that center line command, then one line, then the other line. Now, because it's so skinny, it does not show this broken up as a small line. We could make adjustments to that in settings, but we know that that's a center line anyway, so that's okay. Now, I'm going to show a little trick with this. We want to show that this part is symmetrical. So there's a kind of a neat way of doing that. We're going to come over here and get out of this command by hitting escape. I'm going to come to this center mark and double click on it. And see these arrows that pop up? They allow me to drag the extents of those of that center line a little bit outside, about 1/8 of an inch outside of the object. And what doing this does is it tells anyone looking at it that this circle is in the very center of this object, and that the object is symmetrical across either one of these lines. So the center lines here serve as a center mark for the hole and serve as a line of symmetry, showing that it is symmetrical on either side. All right, now we're ready to start putting in some dimensions. On the front view, we need to show either the distance across flats or from point to point. And because this is a cam that we're using that we need a maximum dimension, I'm going to go from point to point. That ends up being a 2-inch dimension. We also need to know the thickness of the object. Click here, click there. Place your first dimension should be about 1/4 of an inch to 5/16 inch away from the object judged. Okay, and now we're not quite done yet. If something's square, we can assume that it is 90 degrees, but this is a hexagon. So we're actually going to dimension this angle here by clicking on the 2 lines that make the angle. So we click dimension, click one line, click the other line, and notice it will give us a dimension. Now, normally it's not okay to dimension inside of an object. We want to place dimensions on the outside, but sometimes when you've got a lot of space, it's okay to do that on the inside of an object, most of the time with angles. Now, if this started to get crowded, we wouldn't want to do that. Okay, I'm going to hit escape to get out of that dimension command. Now, the one thing we need to do to show that this is a symmetrical polygon is double click on that dimension. And we're going to add space, capital X, and a 6 to show that there are 6 of those in a pattern. Okay, so now we're showing that this is a symmetrical polygon. All right, last thing to do is we're going to show this hole. Now, this hole was created when we created this part as a extruded circle, not as a hole. If it was a hole, one of the things you can do is go to text and put hole and thread note, but because it wasn't made as a hole, I'm not able to select it. So we're going to have to go to dimensions, dimension that hole. We're going to drag this outside of the object, and we're going to add, because that diameter goes through, we're going to edit that, hit escape a couple times, double click on it, and we're going to add space and the word THRU to show that it goes through completely through the part. Enter will get us out of the dimension command. And we have a fully dimensioned hexagon cam. Next up is going to be the eccentric cam. All right, as always, we're going to make sure we have it on the front view, which already it happens to be. We're going to make a drawing from design, open up that sheet. It will remember what we did last time. Let's go ahead and make it a 1.5 scale, just like we did the last time. Oops, I don't know what happened there. 1.5, there we go. Now, just like the last time, I think I will, oops, why? I'm trying to click. And it's not letting me. Cancel it out because I don't know what was going on there. Let me put in base view again. We'll try that one more time. 1.5. There we go. Okay. And now we're going to project our view. Now, last time, if you'll remember, when I did this, those hidden lines didn't show up. And we can hit enter to say to place our views. And again, and this time hidden lines showed up because it remembered the last thing that we did. But we're going to double click on our isometric to make it shaded. Okay, now we're ready to go. Similar to the last time, we're going to show a center mark. What's important about things that are round is the center point. So we're going to put a center mark on that part, and we're going to put a center mark on this part. Okay. Now, we're going to dimension. I'm going to dimension the diameter of this. Now, technically, some variations will tell you that you should dimension things that are solid and not a hole by their profile, as in going over here. So technically, this is a standard for how to do this rather than putting this kind of leader. So we'll go ahead and keep that way. We do know that we're going to need the thickness, just like we did the last time. I want to undo that and show a little trick. Notice that when you do put it in dimension and click on a line like that and pull upward, it sort of snaps because that's a standard for how far that first dimension is supposed to be away from the object. That works. All right, so we've got our diameter, we've got our dimensions. Now this is showing that this hole is lined up vertically with the center mark. I'm going to move this over just a little bit, and we're going to dimension from this line to this line. We can extend that out a little bit. And the last thing that we're going to do is we're going to show the hole diameter and show that it goes through. Pull that outside, double click, add a space NTHRU. And we now have a dimensioned eccentric cam. Next up is the Pear Cam. All right, Pear Cam happens to be in the correct orientation already. So I'm going to go to Drawing from Design, get whatever sheet works. We've been using 1.5 scale. For whatever reason, it remembered last time, but I'm going to make sure visible and hidden edges are turned on before I place my first view. Place, okay, project, click on the view you want to project. I want, again, just the right side view and the isometric. And enter to place those views. Let's shade our isometric. Now this one's going to be a little bit trickier. This one has some arcs in it. I think in the last one, now that I remember, I want to go back to my, I never put my centerline bisector in my, there we go. Okay, I'm going to go back to, whoops, wrong one. Let's go back to my Pear Cam, where I have created a drawing, and I've crowded up my thing so much that, there we go. Had to go find it. All right, so this time we're going to put in a center mark here, and notice that it's not going all the way because it's as if this was a whole circle. We also need to put a center mark up here. Now notice it put that only in this little point right here. And I think I'll fix that by double clicking, and it should allow me to expand. Hit escape a couple times. I'll double click this, and it will allow me to expand it by grabbing that arrow. Oops. And my computer's having a hard time here responding to me, and there we go. Okay, now this one will not allow me to expand that outward. I kind of wish it would. Whoa, I don't want to do that. Let's undo that problem. All right, but it does show a little crosshair where the center of that is, so that will work. Now, we're going to dimension the important stuff, which is where center points are, correct? So because this is a radius, it's okay for us to put a center or put a dimension on the radius instead of where we see it as a profile. So we're going to put that guy somewhere around over here, showing us that radius. We're also going to put this one up here, showing us what that radius is. And now we're going to put the distance between the center points from here to here. Okay. Now we have in this drawing what's called implied points of tangency, and what that means is that where these lines meet appear to be tangent, so we can assume that they are. Those are implied. So this is actually okay. It's showing us where everything is. The only thing left is we've got to show where that, I'm going to move this, this radius one a little bit. There we go. So I can put my whole call out down here. And again, that is 0.25, but we're going to hit escape to get out of the command, double click and edit to say THRU for through. All right. The only thing left now is for us to show that this is a hole by doing our center line bisector. Click center line, top and bottom, and we need a dimension for the thickness of the cam. And we are all dimensioned. Believe it or not, this one dimension right here dictates everything because we have a radius following around this center point and another radius following around this center point and lines of tangency in between, which means that it is fully dimensioned even though we do not have a dimension from top to bottom. We don't need it because the center points are king for things that are round. All right, so there is our Pear Cam. Last one is the Snail Cam. Design, drawing. We notice that we already have the front view the way we want it to be from design. And again, we're going to go 1.5 scale. Just seems to work well. Click OK. We're going to project the view over here and get our isometric. It's okay to go off the paper. I can move it after I'm done. Hit enter. And I can move that down here a little bit. Double click on that to make it shaded. For whatever reason, it did not remember to bring in hidden lines, so let's go ahead and do that. Double click on the front view, make it hidden if it's not already. Close. Now, this little guy slopes down ever so slightly on the Snail Cam that I designed. It may not happen with the one you designed, but that's why I'm getting two little hidden lines right here, and that's okay. Now, this one's going to be a little different. We still do need a center mark. We're only going to put it on the center, though, because this arc changes its length. And we're going to dimension the distance from that center point to right here. Now, this time I'm going outside the views, but that's because I'd rather go to where there's less line going across than follow the rules of putting dimensions in between the views if I can. And we're going to put a dimension from here to here. I think I'll move this over a little bit. There we go. Maybe extend this out just a little so it's not quite so crowded. There we go. Okay, we're looking good. Now we need to define the curve, which is a little weird because this curve is never a specific dimension away from the center point, right? So why don't we either say proprietary or we can make a dimension. Now notice it won't even grab a point on that curve. So we're going to have to do a little cheating thing here. And instead of dimensioning, we're just going to put in a note. So up here above text is note. You can grab that, pull it down here. Now it should point towards the surface. I'm going to do that, and then we can put our note. I'm going to call that, and I hope I'm not sure if I'm wrong or not, in all caps, involute. I wonder if I can hit enter. I haven't tried this before. There we go. Involute curve. Now, I don't know if it is an involute curve or not, actually. I think it is. I hope I don't make any people who teach this kind of stuff mad. If I'm wrong, you can use your own terminology for that. And again, we're going to put in our center line in between those two, get our thickness. And I believe that we have defined, we don't have our hole dimensions. So I think we'll come outside here and say that that is 0.25. Just got to hit escape. 0.25 space THRU to show that that hole goes through. And there is our dimensioned snail cam. All right, folks. Hope that was helpful and that you were able to get them dimensioned. Thanks for listening. See you next time.